Hello students, I'm going to show how to calculate negative feedback gain in a homeostatic control system. Let's solve this question. In an experiment, the mean blood pressure of a rabbit was decreased from 100 millimeters of mercury to 50 millimeters of mercury. After 5 minutes, the blood pressure came back to 75 millimeters of mercury. Calculate the gain of the control system involved. Gain of a control system is given by gain is equal to correction divided by error. So now we have to calculate how much was the actual correction done and how much was the remaining error in this control system. Now to identify that, we have to draw something called as a homeostatic response curve. It has a y-axis and a x-axis. So y-axis is the controlled variable, that is the blood pressure here in millimeters of mercury, and the x-axis is time. Let's draw this values. Now at the beginning it was 100, isn't it? It was 100, and this is the set point of the system. It was at 100 before any intervention. So after doing the intervention, let's say this is the point where the intervention was done. From this point, the blood pressure came back to 50. From 100, it came back to 50. So this is level 50. So this is without any intervention by the control system. From 100, there is a disturbance, it came back to 50. Now, the control system kicks in usually after a small delay, and then gradually it brings it back to a level, and that is 75 millimeters of mercury. So the set point was 100, the original value. The disturbance brought it to 50, and the homeostatic system corrected it back to 75. This is a negative feedback system, that's why it is coming back towards the original value. Now there are two values we have to calculate. One is correction and error. Correction is the difference between the final value after the correction and the change done before the correction. So this will be, so the correction will be equal to 75 minus 50 millimeters of mercury, and divided by error will be the remaining error, that is the difference between the final corrected value and the original set point, the difference between the two. So this is 75 minus 100. So this would be 25 by minus 25, and this is equal to minus 1. So this is the gain of the control system, negative 1, minus 1. And you can see from the formula the error is in the denominator. So if the error is very low, then the gain is going to be higher. So as lower the error, the higher the gain. So higher the gain, effectiveness of the system is higher. Let's consider one more example. Here it was decreasing. Let's consider one more example where the blood pressure was increased. So in this experiment, in adult male, blood pressure was increased by injecting a drug, and after that control system brought it back to 110 millimeters of mercury. You just pick up what is the relevant information over here and then draw the response curve again. So it's y-axis and x-axis. Now the controlled variable is the set point is again 100, but instead of decreasing, here they have increased it to 150, and then it has come back to 110 eventually. So initially it was 100 and this is 150, and it came back to 110, that is the final value. So now the formula gain is equal to correction by error. So the correction is the final corrected value and minus the original value before the correction applied. So that is 110 minus 150 divided by the error is the remaining error, that is the difference between the corrected value and the original set point. So 110 minus 100. So this would be minus 40 divided by 10. So this is minus 4. Now you can see this gain value is slightly higher than the previous one, that's -1, and this is -4, and you can see the error is much lesser compared to the previous experiment. So higher the gain, the numerical value, so ignore the sign, it is negative because of this is the negative feedback system. Higher the magnitude of the gain, higher is the effectiveness of the control system. What if there is no error? If the error is 0, whatever the the change, the correction has completely did it. For example, in this experiment, let's say it went to 150 and it came back to 100 itself. So in this situation, correction would be like, let's say 50, and the error would be 0. If the error is 0, then this formula becomes, the answer becomes infinity. Yes, if a control system is completely error free, then the gain value is going to be minus infinity. In human body also, we have certain control system which have a infinity level feedback, which means the error is absolutely 0. One example is renal pressure volume control system, which we will discuss in detail in renal physiology. Thanks for watching. If you have any doubt, please leave it in the comment. Thank you.